As mentioned earlier, that most surveying measurements are carried out as if the surface of the Earth were perfectly flat. The method of surveying based on this assumption is called plane surveying. In plane surveying, you neglect the curvature of the Earth, and it uses the principles of plane geometry and plane trigonometry to compute the result of their surveys. The use of a plane surveying method simplifies the work of the surveyor. Within a distance of 20 kilometers, the effect of the Earth's curvature on our measurement is so small that we can hardly measure it. Let's look into that. So let's see, they seem to think that 20 kilometers doesn't have a big effect. Well, that's 12 miles, and 12 times 12 times 8 is 1,152 inches. Divide that by 12, and that's 96 feet. So if 96 feet of curvature does not make a big deal to a leveler or a surveyor, we've probably got an issue. Let's look at the next point. Talking about this diagram here, it is going to go ahead and tell us that by definition, the curved surface of a sphere is termed a level surface. I'll repeat that again. By definition, the curved surface of a sphere is termed a level surface. The direction of gravity is perpendicular to this level surface at all points, and gravity is used as a reference direction for all surveying measurements. The vertical direction is taken to be the direction of gravity. In addition, the horizontal direction is the direction perpendicular to the vertical direction of gravity. Let's just say that this could just say right here, the Earth is flat, and we're going to try and talk a bunch of shit in another direction. But that's what they're basically saying. Most surveying activities are performed under the pseudo-assumption that measurements are being made with the reference to a flat horizontal surface. This requires some further explanation. The Earth actually has the approximate shape of a spheroid, that is, the solid generated by an ellipse rotated on its minor axis. However, for our purposes, we can consider that the Earth to be a perfect sphere with a constant diameter. In addition, we can consider that the average level of the ocean or mean sea levels represents the surface of a sphere, and therefore we take it as flat. Interesting. So first, let's take a look at this beautiful picture of the spinning ball Earth and realize that as the world goes through its orbit around the sun, we spend a quarter of the year in each season. So based on that, would you also agree that the South Pole gets the same amount of sun as the North Pole? It would have to, correct? Then does somebody want to explain why we have a gigantic continent called Antarctica, where only one animal really lives? But on the north end, there is not a gigantic ice continent. Someone needs to explain to me how they could be different when, based on the globe, they should be the exact same. So now let's look at the next diagram, and we'll go ahead and take the red line and put it straight through the Earth's axis. And if the Earth is at a tilt, as shown with the red axis there, then why does the green equator get the bulk of the sun? The equator doesn't even make a difference anymore. It's no longer the middle. And if the atmosphere spins with the Earth, then why does the Coriolis effect happen at all? How could the spinning of the Earth cause winds to go in certain directions or cause anything to happen if the entire atmosphere is connected to the Earth as it spins? Should make no difference at all. But of course, we know how the globe earthers work.